5 questions to review for your factoring quiz, which I'm giving tomorrow, Tuesday, February 23rd. Okay, so it's going to be 5 different questions all about factoring. First question, x squared plus 3x minus 28. So I want you to factor this. Okay, the first thing you'll do is check if there's a greatest common factor. You see that there is no greatest common factor because x doesn't have a number there, so there's no number I can factor out. And 28 doesn't have x there, so I can't factor out x. So no common factor. So we're going to move on to the next kind of factoring we know. And that would be to check if it's a quadratic in standard form. So x squared plus a number times x plus a number, and it is. So that means that we could try to find 2 binomials that multiply to get this quadratic expression. So we use the box like this. We'll put x squared in the first top left box. We'll put the negative 28 in the bottom corner box. Pause the video to think about which 2 numbers you're looking for now. Okay, so we want 2 numbers that are going to multiply to get negative 28. And when we add them together, it's going to give us 3 because they're going to be our 2 x terms. Those 2 empty boxes are both going to be our x terms. So let's see, 28. 1 and 28, negative or positive 1, 28 or negative 28. There's 2 and 14, right? One of them has to be negative because it's multiplying to negative 28. There's 4 and 7, so either negative 4 and 7 or 4 and negative 7, and I think we found our answer. Negative 4 and positive 7 is going to add up to positive 3. So those are going to be our x terms, negative 4x and 7x. So now we could start doing the outsides of our box. X times x multiplies back to x squared. X times negative 4 multiplies to negative 4x. And x times 7 gets 7x. And just check that bottom corner. The outside number 7 and negative 4 multiply to negative 28. So now what is our answer? Well, I'm looking for the 2 factors. The factors are the outsides of the box. So x plus 7 and x minus 4, those outside parts are the 2 factors. So first factor is x plus 7. Next factor is x minus 4, and I'm done. Second question, 3x squared minus 24x. So again, I said before we start, first strategy we want to try is to see, is there a greatest common factor? Looking at 3x squared and negative 24x, I do think there's a common factor. So I'm going to make the long rectangle, okay, where we get each factor inside as is, and think about the greatest common factor. Well, both of these could be divided by 3, and both of these could be divided by x. So we could factor out 3x. Now thinking about multiplying back from 3x, to put a number on top so that we get 3x squared, that would be 3x times x. 3x times something to get negative 24x, negative 8. Okay, negative 8 times 3x gets us back to negative 24x. So our 2 factors here are 3x, that's all we had for the left side, like the length of the rectangle, and the width of this rectangle is x minus 8. So that is the other factor here. Now looking at these, 3x, simplified as it could be, can't factor it again. What about x minus 8? Could x minus 8 be factored again? Nope, I don't see an x squared there, right? I don't see any quadratic, I don't see any common factor, so we are done. This is all we needed to do for this factoring problem. Okay, next one, 4x squared plus 4x minus 48. Look for a greatest common factor. Did you find one? I hope you did. Okay, so I'm going to make the rectangle around it, and the greatest common factor that I see is 4. All of these are divisible by 4. I couldn't factor out x this time because if you look at 48, the negative 48, that box doesn't have an x. So they don't all have x in common. All they had in common was 4. Now I'm going to think about what we could multiply back with 4 to get the inside terms that we have. So 4 times x squared gets us 4x squared. 4 times x gets 4x. 4 times negative 12 gets negative 48. So now we have 2 factors. On the left we have 4, that's our first factor. And then on top we have this whole long thing, x squared plus x minus 12, that is one long factor. Looking at 4, obviously I can't factor that again. X squared plus x minus 12, can I factor this again? Well, that looks like a quadratic expression in standard form, right? Our x squared plus something times x, in this case just 1 times x, plus a number, negative 12. So on the side here, I'm going to start another factoring where I'm going to try to find the two binomials that I get when I factor out x squared plus x minus 12. What were those two things that multiplied to get this product? So I'm going to put the x squared in my box over here, negative 12 in the bottom left box. And now I'm thinking about what are those two numbers that multiply to get negative 12. And when I add them, I will get 1 because I just have 1x there. So thinking of multiplying to 12, well, that would be either 1 and 12, 2 and 6, 4 and 3. Well, I think we have it. 4 and negative 3 is going to add up to positive 1. So 4x can go here, negative 3x goes here, and then we'll do the outsides. X times x to get x squared. X times negative 3 gets negative 3x, and x times 4 gets 4x. So we got two factors here. X plus 4 was on this side, and x minus 3 up here. Now, we're going to go back to our problem, because remember that this was just one little piece of our problem. We just took this factor and factored it out into x plus 4 and x minus 3. Let's not forget that we had this factor as well, and we'll bring it down, and the three factors together, 4 times x plus 4 times x minus 3, are our answer. Because if we would multiply all three of those back out, we would get to the original product, 4x squared plus 4x minus 48, that I gave you as the question. Okay. Fourth question here, 2x squared minus 15x minus 8. So first we'll look for a greatest common factor. Looking at 2 and 15 and 8, I don't see a common factor there. Okay. Looking at the variables, I don't see an x with negative 8, so I can't factor out a variable. So we're going to have to go ahead and use our Earmuff method, okay, which is where we're looking for two binomials, but because we have a number out here, we have to take it into account when we think about what we should put inside the box for our x terms. So I call it earmuffs because when I circle the first and the last and put that thing over it, it looks almost like earmuffs. So we multiply 2 times negative 8 and we get negative 16. So now we are looking for a number that doesn't multiply to negative 8, that last number, but multiplies to this number, negative 16, but still has to add up to the number over here, negative 15. Okay, so let's see, 1 times negative 16. I think we got it already, right? 1, positive 1, and negative 16 adds up to negative 15. So we have our answer of how we should break up that x term when we fill in our box. So our box is going to have 2x squared here, just like we did when we didn't have a number in front of x squared, right? That first term always goes in that first box. Negative 8, that last term always goes in that last box. The big question was what we should do with these two x terms, and what we got was positive 1 and negative 16. So now we have our box all filled in. And now we want to try to figure out the outsides. So we like to look at the top row right here and find the greatest common factor. Greatest common factor in this case is 2x. Okay, 2 is the highest number we could factor out of both, and we could factor x out of both. Then we'll think about multiplying back to the inside. So to get 2x squared, we'd have to multiply by x. 2x times x is 2x squared. To get negative 16x, we need negative 8. Negative 8 times 2x is negative 16x. Then to get from x to x, we're just going to multiply by 1. X times 1 is x. And check that last box, negative 8 times 1 is negative 8. So our factors are these outsides. This is one factor, this is the other factor. So our answer is 2x plus 1 and x minus 8. Okay, so those are the two factors that would multiply to the product that I gave you, 2x squared minus 15x minus 8. One last problem here, 6x squared minus 54. First, we're looking for a greatest common factor. Okay, I look at 6x squared minus 54 and I see they're both divisible by 6. So I will factor out 6. Then I'm left with x squared, and negative 54 divided by 6 is negative 9. So my two factors are 6 times x squared minus 9. Now I need to check if one of those factors could be factored again. I hope that looking at x squared minus 9, you see that this is a difference of two perfect squares. I'm going to show you what I mean, just in case you don't know how to do that in your head already. Okay, so x squared and negative 9 give us this box and this box. What happened to the other two boxes? Why do I not see an x term? Well, it must be that there was the same thing in those two boxes, but one was positive and one was negative. We call that a zero pair. They added up to 0. So what would those values be? Well, x times x gets me x squared. And to get negative 9, I want to think in terms of a perfect square. What's a number I multiply by itself to get 9? That would be 3. But since I got negative 9, one of them is negative. So look what happens when we fill in those boxes. We multiply negative 3 times x, and we get a negative 3x. We multiply 3 times x, we get 3x. And that is our zero pair. Negative 3x and 3x equals 0. So that's why we did not have an x term in the question. We just had the first term x squared and the last term negative 9. So the factors we got here are x plus 3 and x minus 3. Going back to the problem, x squared minus 9 became x plus 3 and x minus 3. And here's the 6 that we had from before, that factor that we factored out first. And with that, we are finished with all 5 problem types that I plan to put on the quiz tomorrow. If you have questions, feel free to email me. And if I made any mistakes like I did last time, please let me know. I hope I didn't. And good luck studying, and have a great night.